Day 1 in geometry. And our day 1 notes are going to start with this title here. We are in Unit 1, and Unit 1 is all about lines and angles. Lines and angles. I'm going to draw a little line under that just to separate the title from the rest of my work. Now, what we will start with today is we're going to draw a line. Now, at your tables in the little rectangle bins, there should be a ruler. So everybody grab a ruler. And with that ruler, we are going to just trace a straight line across our paper. I'm going to do it going all the way across, like that. And on each end of this line, I'm going to draw arrows. So start by drawing a line with arrows on the ends. Does anybody know what does it mean when there are arrows on the end of lines in math? What does that mean?
It continues.
It continues. It goes on forever. It never ends. There's no stopping point. So a line does not ever end. There's no start. There's no finish. It goes on forever. It continues. So we're going to label this as a line. Line. And we're going to write continues forever in both directions. So we just drew a line. It continues forever in both directions. There's no points, just arrows going in both directions. Now, after we write that definition, we are going to draw another line, but this time we're going to make it a little smaller. I'm going to use the centimeter side of my ruler. And starting from that first line, I'm going to trace over to about 10 centimeters. About 10. And is that you, Diane?
It always is. It never stop.
That's okay. Do you know how to put that on silent?
Yes.
Okay. Okay, so I've drawn another line. But this time I put end points. There's points on the end. This does not continue forever in both directions. And what we call this, because it is no longer technically a line, this is a line segment. Yes, line segment. Basically, this is a piece of a line or a section of a line. Segment just means a section, a smaller portion. So we will say a section of a line with end points. End points are just those dots, those circles that are filled in. Okay. So now we know what a line is. Now we know what a line segment is. And we are next going to learn another fancy word. This one does not have a picture. I'm going to get, let's see, a different color. use, yes. I'm going to write the word postulate. 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 So in geometry and in math in general, a postulate is just a fancy word that means a rule. It's a rule. A rule. In math that we follow. It's a rule in math that we follow. So now that we know what a line is, a line segment is, and a postulate, we can put all of this together and we're going to learn about that worksheet I gave you earlier. You'll notice the title says segment addition postulate. Segment addition postulate. That means that in this worksheet, we're using a rule, a postulate, a rule, to add segments, line segments. Okay, so for example, I'm going to create a more simple version of a problem, not on the worksheet. So below here, let's actually write that whole title, segment addition postulate. This time I'm going to write it, and I'm probably going to highlight it. I'm going to make it big. Segment addition, ADDITION, postulate, POSTULATE. Segment addition postulate. And I'm going to use a highlighter and just highlight that title, because that's what we're really talking about today. Each of you should have some highlighters at your desks, at your tables. If you don't and you need some, feel free to get up and look around the room if there's any not being used. Share with each other. And I'm going to give you a written word definition for segment addition postulate. And then we're going to give an example. So the actual definition of this is, if point B is between point A, C, then we're going to write bigger here, AB, the line over it, plus BC with the line over it equals AC with a line over it. Now, I'll tell you what this means. I'm going to highlight this formula as well. I'm going to draw a little picture to explain. So I'm going to draw a line segment again, and I'm going to make that segment about 3 inches long, 3 inches roughly. I will put points on the end. And somewhere in between those 2 points on the line, I will put a third point. About like that. And then we're going to label those points. First is A, then B, then C. And here's how we use postulate. If this is A, B, these 2 points, AB with a line over it means the distance from A to B. So that might be labeled with, let's say, 9. We'll put a 9 there. Then from B to C, let's say that's 32. What the segment addition postulate tells us we can do is if I know what AB is and I know what BC is, I can just add them together and I get all of A to C. So I know the 2 parts, but I don't know this whole length. So what I would do here is AB is 9. So I'm going to write AB, and under that, I'm going to put the 9. Yeah. Perfect. BC would be 32 equals, and that's going to give us our AC. So
Okay.
9 plus 32 is what? 41. Good. So in this problem, if the question was, what is the length of AC? AC equals 41. Yeah. Makes sense. Okay. Now, this can get a little trickier whenever we don't know the lengths. Sometimes they give us things like X. So let's look at, I'm going to label this as an example. We'll do another example right below. And this time I'll do 3 points, trace that line. And below those 3 points, I'm going to do kind of the same thing I did for that first example where I'm drawing the whole length of that line segment with little tick marks on the end just to show that it ends there. It's measuring a length. And again, I will label A, B, C. And this time we will put, let's draw a line here to separate the examples. Let's say this is 25. This is X plus 3. And this bottom length, I'm going to actually give you a length here. From A to C, the whole thing. Let's say this is 45. So I'm still going to use the AB plus BC equals AC. I'll let you guys kind of copy that down first if you need to. I'm just going to copy that formula down. AB plus BC equals AC. And just like we did on the first example, to figure out my problem, I just looked and said, okay, AB is between A and B. It's 9. I'm going to put 9 there. BC is between B and C. 32. I'll put 32 there. AC is all of it added together, and that's how we got 41. So this time, let's write the values the same way. So what would A be? Yes, 25. I'll bring down my plus sign.
X plus 3.
Yes, BC is x plus 3. Equals, and what's AC?
X plus 28.
Yes, technically that is right. But is there a number for AC?
45.
45. 45. But you are correct as well. I'll show you how we're going to use that. This 45 measures the whole length from A to C. 45. Okay. So I'm going to now zoom in on just the numbers. And we're going to do something with these. First, we have an equation with x. That means we have to solve for x. So I'm going to draw a line through my equal sign. Yes, and we're going to solve it. So over here on this side of my equation, let's make sure we all understand what like terms are. Does anybody know what like terms are?
Yeah.
What are like terms?
They're similar.
They're by themselves, they don't have a variable.
They're by themselves, they don't have a variable. Like terms could have a variable,
Exactly the same.
Well, yeah,
but they're the
Yeah.
same.
but in this one it'd be 25 and 3.
Yeah, okay, so I'm going to pull out a sticky note. Okay, each of you should have sticky notes at your tables. If you do not, let me know. I can give you some more. I have lots over here. I'm going to grab a sticky note, and this is just a quick review. You might already know this, but just in case you don't, do you guys need more? Okay, I've got a whole thing of blue or green. If anyone else needs more sticky notes, I have extras up here. Feel free to grab them. But just so we know, like terms, I'm going to be saying this a lot. Like terms. What this means is it's numbers that have the same variable or no variable. So I'm going to write numbers with the same variable. And for example, if I had 3x plus x, are these like terms?
Yes.
Yes.
Because the other
Why?
X.
They both have x. They both have x. These
Mhm.
are like terms. So if I have 3x and I add another x, what do I have? 4x. Good. 4x. So whenever we both have x's, we can add them together. Another example. Let's say I have 3 plus 2x plus x. Which two terms are like terms?
2x plus 1x.
2x plus 1x. This is an invisible 1 here. If there's no number, we know there's just 1x. So 2x, 1x. Can I add that 3 on there? No. 3 does not have an x on it. So it's not like terms. So I can only add 2x plus 1x, which is 3x. So I did that. And this 3 would just come over beside it. 3 plus 3x. Because I cannot combine those. There's no x. Okay. Does that make sense? What we can and can't put together? Okay. So, that is just a little side note. And if at any point, if I move a note over and you were not done writing, please stop me. I'll wait for you if you need. But I'll put that to the side. So now looking at just this side of my equation, 25 plus x plus 3. What like terms do I have?
25, 3.
25 and 3. So what's 25 plus 3? 28. And what comes down?
X.
Yes, my x is still there. So I'm going to bring down plus x. Okay, I'll bring down my equal sign. I'm going to bring down my 45. Now, I'm trying to get x by itself. How do I get rid of 28?
You subtract minus.
Yes, let's subtract 28. If I do something on one side, I have to do it to the other side to keep it equal. So minus 28, minus 28. And what happens to my 28s? They cancel. So x comes down.
Yes.
Equals. And now what do I do here?
18.
Is it 18?
17.
Oh, 17. 17. Let me grab my calculator so I can do it along with you guys. Where is my calculator? This. Yeah, so if you do not have a calculator, make sure you grab one. Do you have one? I don't know if you were in here. Okay, good. Perfect. Perfect. I think everybody has. Okay, so you're literally just typing 45 minus 28. Enter 17.
Yeah.
And so my answer is x equals 17. And we're done. Not so bad.
So you have to do that way. Oh, you go ahead.
Diane, what were you asking?
I say, so we have to do it this way, because I had already,
How did you do it?
I just subtracted the 18, did the regular way. Not
Yeah.
doing it that way.
Well, hey, if you want to do it that way, like, did you, like, what did you write different than I wrote?
Well, I figured that the X was 17.
Well, if you got the right answer, then I'm fine with that. That works. If it works, it works.
Okay.
What was your
I did.
Oh, okay, perfect. Same question. Good. Good. So there we go. That's our answer. I'll leave this up for just a moment as people continue writing, and then we are going to look at our worksheet next. We'll do the first couple of problems together. Okay, am I safe to move this? Does anyone still need it? Anyone writing still? Okay. So I'm going to just shift that up a little. And I have written, you'll notice I wrote under name, answer guide. You are going to write your name, okay? I am just putting answer guide because I'm going to have all the answers on here by the end of the day. So we are now looking at number 1. Now they use different letters, H, G, F. So that's okay. It's the same process. Basically, what we're doing is we're taking the first section plus the second section equals the third section, the large portion. Okay? So sometimes using some colors can help. I'm going to highlight those sections in different colors here. Let's do orange. So what is labeled above my first line segment?
2x plus 20.
2x plus 20. That's my first section.
Mm-hmm.
What is labeled above my second section? 7. Good. And what is the total line segment labeled as?
Plus 20.
X plus 20. Wow, that's a little dark. That's okay. Okay, so I am labeling this to help me figure out what goes together. The two smaller pieces get added together. They're equal to the big piece. Too small, equal big. So I'm going to write an equation here. Which things am I adding together here?
2x plus 20,
Uh-huh.
plus 20.
Yes, so let's write 2x plus 20. And what do I add to this?
7 plus 20.
So x plus 20 is going to be our
90.
equal to,
You're not
because
plus 7.
I'll show you right here. The number on the bottom goes after the equal sign. The numbers on the top get added together, right? So the numbers on the top, 2x plus 20, that gets added
Plus 7.
to 7. Yes. So plus 7
Equals. Plus 20.
yes, and that equals x plus 20. X plus 20. Now we have a tricky problem here. But it can always be made a little bit easier if we draw a line through our equal sign and we think about it one step at a time. So, first, let's just hide one side of the equation. Let's just hide it. I'm going to cover up the other half with a sticky note for now. Just hide it. And over on this side, do I have any like terms?
20 and 7.
20 and 7. Let's add those together. 20 and 7. When I put them together, I get 27. And what comes down?
2x.
2x.
And your plus sign.
And your plus sign. 2x plus 27. Okay, so I'm done with that. I'll bring down my equal sign. Now let's look at the other side. Can anything be combined here?
Yeah.
No, because they don't both have x, so I'm just going to bring that down. X plus 20. Can't do anything yet. Okay, so now I'm looking at my whole problem. What do I need to do when I have x's on both sides of the equal sign? Combine like terms, yes. So when I combine like terms, am I just going to do 2x plus x, or do I need to do something different?
2x minus x.
Minus x. Okay, so what we need to do is when we are on opposite sides of the equal sign, I'm going to use a color here and highlight what we're looking at. I have like terms on opposite sides. Whenever they're on the opposite side, we have to do the opposite thing to combine them. So instead of adding x to both sides, we're going to subtract x from both sides. And we'll draw a line. And the reason we want to subtract instead of add is because when I subtract x from x, what happens? It cancels. It gets rid of the x over here because we don't want it over here. We want it over there. So what's 2x minus x?
X.
Just x. X by itself. What comes down? Plus 27. Bring down my equal. What else comes down? 20. That looks a lot nicer, huh? Okay, so now I have x plus 27 equals 20. It's like a brand new equation has been written. How do I get x by itself? Subtract 27. And really what we're doing again is the opposite because 27 and 20 are like terms. We're combining them. Minus 27. Minus 27. What happens to the 27s? They cancel. We cross them out. X comes down. Equals.
Minus 7.
Yes. You're going to get a negative number here. 20 minus 27 is -7. -7. So do not forget your negative sign, because if you write +7, that won't be right. X equals -7. And that's your answer. There you go. Okay. Very, very good. So let's look at, let's not look at number 2. That one's just like number 1. Let's look at another problem, like number 3. Before we start number 3, does anybody still need to see this? Or can I move it? Okay, I'm going to go ahead and move it, and we'll look at number 3 now. So remember, we're adding the 2 smaller line segments, setting it equal to the larger line segment on the bottom. So for this problem, what should I begin writing? What's the first segment?
3 plus X
Good. 3 plus X
plus
plus
X plus 6
good. X plus 6
equals
equals 7. And if it helps to kind of label your picture, you could always do something like this. I know I'm adding these, and they're equal to that. If that helps. It might not help. Everybody's different. Okay. So once I have an equation written, again, I like to draw a line through the equal sign. Diane, you taught me that, and I have never forgotten it. I'll always do it now. What should we do from here? Yes, let's combine like terms. On the first side of my problem, what can I combine? 3 plus 6, good. So 3 and 6 can be combined, and what is 3 plus 6? 9. Okay. Is there anything else that can be combined?
The X's.
The X's. So X plus X. What is that?
2.
2X. So I'm going to write plus 2X
Equals 7.
equals 7. Good. Okay. Now I have 9 plus 2X equals 7. What would I do from here?
Move 9.
Move my 9. I want my 9 on the other side. I'm trying to get X by itself. So what would I do to get rid of 9? Minus 9. That's a positive 9, so we do the opposite, which is minus 9 on both sides. What happens to the 9s? They're gone. They cancel. What comes down?
2X
2X
minus 2.
equals, yes, 7 minus 9 is negative 2. Or minus 2. Okay. Now, I have 2X equals negative 2.
Divide.
Divide! Yes, remember, a number next to X is multiplication. 2 times X is what that means. So, to get rid of a number, these are on opposite sides, we're going to do the opposite thing. The opposite of times is divide. So, we're going to divide by 2 on both sides. And what happens to my 2X divided by 2?
X minus 1.
X, yeah, it becomes X equals, and you are correct, negative 2 divided by positive 2, negative 1. X equals negative 1. Very nice. Okay, so that was number 3. That was number 3. I think we'll do one more together. Then I want you guys to try some on your own. Let's do number 4.
Number 5.
Number 5, you want to do that one? Okay, let's do number 5. Okay, look at number 5. And now I have another problem. What should I begin with? Good. X plus 1 comes first. Plus 7 equals. Good. Equals 2x plus 5. Okay, yep, let's draw our line through the equal sign. Now, guide me. What do we do?
Like terms is the 1 and the 2.
Yeah, like terms. Okay, so what do I combine here?
The 1 and 7.
Oh, this is a
I
7.
mean, I'm sorry.
That's okay. That's okay.
I understand too.
That's all right. So 1 and 7 are like terms. I add them together and I get 8. So I'll bring down x plus 8 equals. It doesn't look like I can combine anything over here, so I'll just bring it down. Okay. Now what?
Do
You take the 8 and the 5. Well,
You
got one
could.
outside.
You could absolutely do
those are
that.
like terms.
I was thinking of the X's.
Or we could do the x's.
Yeah.
I personally like to get all my x's together first. Because once your x's are together, usually the rest of the problem flows a little more smoothly.
So all the like terms.
So I'm looking at my x's. I have x's on opposite sides of the equal sign. So I could get rid of 2x and bring it over here, or I could get rid of x and bring it over there. Which one do we want to do?
I got rid of X.
Yeah, I would do that also. I would get rid of x,
We're gonna bring it over here.
then bring it over here. That way, we don't end up with a negative x. You can do it the other way, but I like getting rid of the smaller x. Let's get rid of minus x. Where else do I subtract x? Yeah, from the 2x. Good. My x's cancel. They are gone. And I'm going to bring everything down. 8 equals, what is 2x minus x?
X.
It's just x, 1x, good. And what comes down?
Plus 5.
Plus 5. Okay, now. We still have the same goal. We want to get x by itself.
Subtract 5.
Yeah, let's move over. Now, are we going to move the 8 or the 5?
The 5.
The 5. The 5. So if I want to get rid of plus 5, what do I do? Subtract 5. Okay, my 5s will cancel. Now I have x all by itself equals 8 minus 5 is 3. And there you go. It's okay if it doesn't say x equals 3. 3 equals x is just as good. Just as good. 3 equals x. There we go. Now, does anybody have a question? Yes, yes. Go ahead.
I moved 8.
You moved 8. Did you still get 3?
Minus 3.
Minus 3. Okay, so let's talk about that. Let's see. If I have 8 equals my x plus 5, and I get rid of the 8, right? So did you do minus 8? Minus 8. Okay, so minus 8. Minus 8. That cancels my 8s, and I get 8 minus 8 is 0. Equals x minus 3. It doesn't say x equals minus 3. It says 0 equals x minus 3. That's why drawing the line helps us remember where the equal sign is. It's tricky.
I never did it like that.
Yeah. Uh-huh.
I know since it's a zero here, you can't add that 3 and limit.
You can though. You can. If you can still do this, because watch. Now I want to get rid of my -3. Let's do +3. Plus 3. And now I get 0 plus 3 is 3 equals X. You do still get the right answer. You can do it that way. But we have to be careful not to move the equal sign, because if you move the equal sign, you might get the wrong answer. We have to be so careful. So careful. Does that make sense, you guys?
Yeah.
Okay. Okay, good. Yeah. If we do it this way, it does take a little bit longer, but you still can get the right answer. Just an extra step in there. Okay. Okay, so what we're going to do now is the rest of this worksheet. Now, if you are somebody that is super sneaky fast, maybe you worked ahead. I have some more problems for you to try. But I'm going to set a timer for about 15 minutes. And I want you guys to try these on your own. And when that timer goes off, I will give you your answers. And you tell me if there's anything that you did different. Maybe you did something correct and it really clicked with you and you want to share it. That's great. Or if you did something wrong, share that too. Because our mistakes really help your classmates learn. Mistakes are one of the best ways to learn. So I'm going to pause our recording and I'm going to set a timer. Work on the rest of this worksheet. See if you can do them on your own. All right, so for number 2, I have an answer key here. What I'm going to do is just read off those answers and you tell me if you got something different. So for number 2, you should have gotten X equals -8.
Yeah. Oh.
For number 4, you should have gotten X equals 6.
Yeah, I'm thinking.
And for number 6, you should have gotten X equals 4. Good. Now, for those 3 problems, does anyone have any comments, any questions, any things they noticed? Or did anybody get these wrong and maybe want to see it worked out again? Yes, go ahead. Jose.
Number 4 long.
Number 4. What did you get for number 4?
X equals 18.
X equals 18. Let me do this.
Can we work them out?
Yes, we can work them out.
That's what I got first. Yeah, but then I got a 6.
So, you said you also got X is 18?
I did to begin with.
Oh, okay. So maybe we'll see some similar things. So, Jose, I appreciate you speaking up. Tell me, how did you begin your problem? What did you write?
I added the 6 and the 6.
Okay, so 6. Oh, okay, so let's start with your equation. Did you have 6 plus 2x minus 6 written?
Yes.
Okay, so let's write that. 6 plus 2x minus 6. And did you also put equals x plus 6?
Yes.
Perfect. Okay, so you said at your first step, you added 6 plus 6, right? Okay. Does anybody see the mistake?
Yeah.
Should be 6 plus
This says -6. Ugh, those signs, they get us. So because this is just a 6 with no minus in front of it, it's positive. But if there's ever a minus in front or a negative sign, we do have to treat this 6 like it's a -6. So to combine these, we can either do 6 minus 6 or 6 plus -6. Now, in your calculator, let's make sure we all know how to type in negatives. So at the bottom of your calculator, right next to the period or the decimal, there is in parentheses a minus sign. Push that first, and it will pop up on your screen. So there's -6. There we go. If I add that to 6, I get 0. Or 6 plus -6. That's also 0. 6 minus 6, that's also 0. So that minus sign, I bet that threw off a couple of you. So if these, when I put them together, equal 0, what do?
They cancel each other out.
They cancel each other out. Yeah. They just cross out. You could bring down 0 if you want, but that 0 is just going to get crossed out later. It doesn't do anything. So you're just going to bring down 2x. Okay? Now, does this make sense why I'm not bringing anything down? Okay, good. So I have 2x equals, and then what do I bring down now?
X plus 6.
Good, x plus 6. So now from here, where do I go?
You subtract
Sure.
1x.
Yes, subtract my 1x, my x, both sides. What happens?
X equals 6.
Yeah, these cancel. 2x minus x is just x.
Yes.
And that equals 6. There we go. Yes. Yes. Awesome. Okay. Any other questions on number 4? Good. I hope that cleared things up.
Ms. Taylor,
Yes.
I got the same exact answer and I basically did the same thing, but my equation was longer somehow.
Your equation was longer.
I can explain what I wrote down.
Okay, tell me.
I did the 2x minus 6 plus 6 on one side,
Okay.
and then I had equals x plus 6 on the opposite side, like it's up there.
And then like this, x plus 6. Is that your equation?
Yeah,
Okay.
but then I
So,
put the
yeah.
division sign for the 2x, and I subtracted x, like the division symbol for the underline.
Mm-hmm.
For your 2x, I put negative x there.
Okay.
Then-
So you did like negative x.
Yeah, and then on the x plus 6 part, I had the negative x underneath that x.
Okay.
So I crossed them out,
Yep.
and somehow I came up with x minus 6 plus 6 on one side.
Yep.
Then I added 6 to the negative 6 on that side, and then
Over here. So you did negative 6 plus 6.
yeah,
Okay. And what'd you get?
well it canceled out where I had
Yeah, it
x
canceled.
plus 6.
So then you got, what'd you do at the next step?
I had it written down as x plus 6 equals 12.
X plus 6 equals 12.
Because he added
Ooh,
6.
I know what you did. Okay. So you added 6 to your minus 6, right?
Yeah.
And you did
canceled
that on both
out.
sides. Okay, that's correct. You can do it this way. And now you have x plus 6 equals 12. And then what'd you do?
Subtracted 6 from both sides.
Yes. Guess what? This is also
As
right.
I said, it had me
Yes.
confused because I was like, how did I do that? When I was
In
thinking?
math and geometry and algebra and all of these, especially the higher level classes, there are a million different ways to solve these equations. As long as you follow the rules.
Very different like that.
How was yours? Was yours
No.
kind of like this?
No, every answer is good, but mine is different.
Yours is different. Are you? Let me think. Do you know Geom with Skinny Blonde? Do you know him?
With candy?
Yes. So he showed me the way that he does it, and it's totally different than this.
Yes.
But it's
That's
correct.
what I do.
It's right. If it's getting you the right answer, that is fine with me.
I never put the line.
Yeah.
I do that. When I do the it's wrong.
So as long as you're keeping your work
I
organized,
just put like term, that's it.
and that works. That works. Yeah, everybody does it differently. If writing it out the way I'm doing it feels, not like your best method, maybe you learned it a different way, that is okay with me. As long as you're still doing every step, being careful about what you're doing, you should be just fine. Okay. Any other questions, comments about these problems? Yes. Number 6? Yes. Did you get a different answer for number 6? What did you get?
10.
You got 10. Did anybody else get 10 for number 6? Okay, well, let's see. So, tell me, what did you begin with? What'd you write?
It's the X's later.
Okay, so your original equation, did you do x minus 1 plus x plus 3?
Yeah.
Okay, so I'm gonna write that first. X minus 1 plus x plus 3, and you get equals 10? Yes? Okay. So tell me what you did first. You combined like terms, right? What you said? So what did you combine? The x's. So x and x. And what did you get when you combined them? 2x, that's correct. 2x. Okay, then what? Okay, so -1 and 3, right? What'd you get there? 2. Okay, that's right. 2x plus 2. What do we bring down? Equals 10. Okay, so now what do we do from here? What'd you do? The 2 here. Okay, so you added 2 instead of doing -2. Yeah, that happened. No big deal. You see it now, though. That's good. You get 2x equals 8. What would we do last?
Divide by 2.
Divide by 2. Good. And 8 divided by 2 is 4. There we go. Good. Very good. Okay. Anything else? You writing that, Diane?
Yes, just had it backwards. I had to switch
Oh, that's
where the
okay.
2x is plus that. I
Uh-huh.
just had it backwards.
Okay, that's all right. That's all right. You got the right answer. Okay. How do we feel?
I can say this much so far, it's easier than algebra 2. Like
You think
said.
so?
Yeah.
Good. Most people will agree. Yeah.
I think it's pretty similar. They're just longer equations.
Yeah, there are some longer steps. But luckily we don't deal as much with actually we don't deal at all with like quadratics or systems of equations. It's all just one equation. Yeah. So it's not like, okay, now I know what this is, now how do I do that? And now I gotta do this, and they get long in algebra too. So guys, that's our lesson today. It's 11:45. This class technically goes until 11:55. However, I usually like to give you the last 10-15 minutes to work on your exit ticket if you have one for the day. Today, your exit ticket is just filling out that classroom agreement, telling me the days you can and cannot be here. Anything else you want me to know, please turn that into the turn-in tray. But other than that, you guys are dismissed. Please put your green folders back in the pockets. That is where I give you your graded work back. If your folder is not in a pocket, I can't give you your stuff back until I see you again. So, that's all today.
Can we turn this in?
Your worksheet will go in your green folder. Yes, that's just for you to keep, to look back at for future problems, but that's all, guys.